Welcome to your first video lecture. This is lecture 731 on hyperbolas. You can see here I got a list of things. If you're following that sheet that I gave you, you know that you should have done the study notebook page 101 objectives. The vocabulary could either be listed there, or you can do it on the Cornell notes that I provided to you. I gave you 3 pages. You need to make sure that they're all done. You're going to want textbook pages 442 to 445 open so that you can look at some things. You're going to complete the note page front and back. On the front, you've got definitions, standard form, and then there's some questions and bonus things on the back of that first page. Also, you'll be completing the guided practice for 1A, 1B, 2A, and 2B on the pages provided. And then at the bottom of that page where you're doing your work, you're going to give me one question. You're going to give me a good question about the lesson or about the topic, and we've talked about that already. A reminder, you can and probably should hit pause at various points along the way so that you can go back and rewatch something or stop so that you can get a breath or do a problem, do some calculations. I'll give a little pause, but I'm basically assuming that you're going to hit pause and do your work and then start it again and keep going. You can also, it says that you can stop, rewind, and rewatch any portion of the video, the whole thing again if you didn't get something, and always remember that I like chocolate. We're going to start off by defining the hyperbola in a couple of different ways today and a couple of different ways in the next lesson. Geometrically, you can see here it says that a hyperbola is defined as the curves of intersection between a right circular conical surface and a plane that cuts through both halves of the cone. Feel free to pause and write that down. And what does that look like? Well, we looked at this before. There it is. It's sliced this way, it's a circle. It's sliced that way, it's an ellipse. It's sliced this way, it's a parabola. And then today, if it's sliced, that plane slices straight through both cones, it looks like that, a hyperbola. Another way that it's defined is algebraically. And it was good old Descartes that kind of fused these two things, the geometric way that the Greeks used to do it and the algebraic way, which was the brand new science of the day. He algebratized the geometry of it. And he defined it as equivalently as the locus of points where the absolute value of the difference of the distance to two focuses is a constant equal to 2a, the distance between its two vertices. Now that's kind of hard to visualize. Let me give you a quick visual on that. We did this already with some other parts with parabolas. Let's do this with ellipses. We know that if we move this piece around the circle, the ratio of PF to PQ stays the same for this type of eccentricity. If I move this out, I make it more eccentric. It doesn't matter if I move this point around, the eccentricity or the ratio of PF to PQ stays the same. So that's how we define an ellipse. Now, here's how we would do that for a hyperbola. And we'll talk more about this in the next lesson, tea time. That if I have the ratio of P to F and I compare that of P to Q, that ratio always stays the same. No matter where on that hyperbola I am, that ratio of those two lines stays the same. I can change the focus point, I can change the shape of it, that changes the ratio, but once I've established where the focal point is, any point along that parabola or that hyperbola will have that same eccentricity. It has that same ratio of PF to PQ. You see what makes it more eccentric or less eccentric here? Less eccentric, more eccentric. So that's kind of that second definition. And what they've done with that is that they've taken that, and you can see in your book on page 443, they've taken that basic definition as this difference in the absolute values, and they've turned it into the general form. Okay, now it's very similar to that ellipse. I mean, if you look at the standard forms for the ellipse and you look at the standard form for the hyperbola, what's different? Yeah, it says minus instead of plus. And so in one sense, I kind of think of this thing as being inside out. Kind of think of ellipses or hyperbola as being an inside out parabola. It's broken and flipped around the other direction. Now, this is being the place where you're going to want to pause and you're going to look at page 443 and you're going to want to copy in onto your notes the standard form of equations for hyperbolas. I give you some space there. Write all that stuff down on your notes right now. Did you write all that down? Well, good. You better. Because you're going to need that sitting by you as you do these problems. Remember how we did this with parabolas and with circles and ellipses, that you just go down the series of steps and establish what all the parts are. So you see there up here that if it opens up or down, then the y comes first, and then x. Or if it opens left and right, the x comes first minus the y part. And then if you see on page 442, they used the positive and negative A and positive and negative B to give us four corners of a rectangular box. Positive A, positive B. Negative A, positive B. Negative A, negative B. And negative A, positive B. And that is kind of the constraints there for where the hyperbola is going to fit. It's the four corners of the rectangular box. The asymptotes that define the shape of the hyperbola can be drawn as diagonals of the rectangle that extends beyond the rectangle. You can see that. They've drawn the red dotted lines in the picture. The transverse axis is the axis that connects the vertices and intersects the hyperbola. The conjugate axis doesn't go through the hyperbola at all, so it's pretty easy to determine which one is which depending on the orientation. So what I want to give you now, since we've already done the kind of method with this before with ellipses and whatnot, is to give you a strategy here for going about these problems. And you're going to want to write this down probably, or stop and whatever you need to, but here's what we're going to work with. Determine the standard form equation and orientation of the hyperbola. Look and see if y or x comes first, and then determine whether it opens left and right or up and down. Put the thing in standard form if it's not already in standard form. We worked with that a little bit. We'll give you one more demonstration of that here in a few minutes. Secondly, you're just going to want to find what is A, B, C, H, and K. Then you're going to use A, B, C, H, and K to derive the address for the center, the vertices, the focus. You've got, what was that? The transverse axis, the conjugate axis, and the asymptotes using A, B, C, H, and K. Then I suggest you should graph those asymptotes when you're doing this on your graph paper. Just get those lines in there because then you know where the hyperbola has to be. Put dots on your graph for the vertices and foci. There's two of them, so we call them foci, focuses. Then you just sketch in the hyperbola that goes through the vertices and stays within the asymptotes. And then you can always use the conic section app, which you've got on your TI 84. Go to apps and you scroll down. Conics, choose conics, and there you go. You got your choices. You go to 3, and if you ever forget, it shows you the picture and it shows you the formula as well. You plunk in the numbers and off you go. That's what I think you should do. And you know, I'm your teacher and I've done this before, so let's see how this goes. Okay, let me give you an example. In addition to example 1, let's start off with this one. And we want to do what we said, strategy number 1, determine the standard form equation and orientation of the hyperbola. So look at it. You see you got x plus 8 minus y minus 4. And which is it? Is it the top one there? Or is it the bottom one? Is it this one or this one? I mean, this is pretty easy, pretty obvious. It's the top one. And so which way does it open? Say it out loud. Yeah, okay. I'll go with that. Sounds good. So we put it in the standard form. It has to say x minus h. So what must h be? Negative 8. Y minus k. What must that be? 4. And then we change the 64 into 8 squared and the 36 into 6 squared. Pause if you need to think about that. Step 2, if it's in standard form, we can see A and B and H and K. So we already said A is -8. B is, oops, that's not -8. What am I thinking? A is 8. B is 6. C is derived by taking the square root of 8 squared and 6 squared. So C is 10. And H and K are right there as well. H is -8. K is 4. From this you can calculate the asymptotes. From this you can graph the vertices and the foci. And then you can draw that hyperbola that goes through the vertices and stays within the asymptotes. No problem. And remember, you can always come over here. Since we've got A, B, H, and K. And we can select what? We can select the first one. Please. And we plunk them in. A was B. Or A was 8. What am I talking about? A was 8. 6. H is -8. And now I can put thanks a lot. -8. And K is 4. We hit graph. Let's see what it looks like. And it should correspond to what you've drawn on your paper. Piece of cake. Let me get you one more thing here. And that would be, well, an example 2 kind of thing. When it's not in the right kind of form. We gotta get it in that form, and then we do all those steps again. X squared minus 4y squared minus 6x minus 8y equals 24. We did this already with some of our other things with ellipses. Let's go ahead and complete the square with both sides. Feel free at many points here to hit pause and you can just look at it, okay? I'm going to do that myself. Look what I have done. I left some space here for completing the square for both of these. I factored this already and got it ready for me to put it in the right form. Half of -6 is 3. 3 squared is +9. If I add it here, I add it here. Half of -2 is -1. That squared equals 1. Because this is multiplied by this -4, I have to include it over here as well. So I put this in its right form, in the completed square form. X squared minus 6x plus 9 equals x minus 3 squared. And the y squared minus 2y plus 1 equals y minus 1 squared. This side 27 plus 9 minus 4 equals 32. It has to equal 1 though. So if I divide everything by 32, here's my form. And from there, I can pick out what is A, what is B, what is C, what is H and K, etc. Hit pause now and do that math. And the answers magically appear. Did you get these numbers? If not, go back. Look at your work again. I have approximations there for those numbers. Feel free to type those in to your TI-84 conic section. See what that looks like. That's it for today. We'll talk to you when you come to class.